Hello, geometry students. I hope you're doing well. We are continuing in chapter 6, and we are in chapter 6-7, which we are calling the taco section. What I would like for you to be able to do by the end of this lesson is to classify polygons in the coordinate plane by applying their properties and definitions of just specific types of polygons. So let's jump right in. We are classifying quadrilaterals in the coordinate plane or, on a graph. So we're going to need to be applying quite a bit of algebra skills today. So I want for you to recall two valuable formulas. One valuable formula is the distance formula. And the reason this is helpful is because it's going to tell us how long sides are, which is pretty helpful because we know if two sides are congruent, that's going to be, information for a particular type of shape. So the distance formula is going to be the distance is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. And I am going to box that in or bubble it in or something because that is pretty important. You're going to use that distance formula over and over and over. We also have slope formula, and this is going to tell us if lines are or are not parallel. So that's why these two formulas are valuable. We need to know how long sides are, and we need to know what direction they're going to determine if lines are parallel or not. So your slope formula is m is equal to y2 minus y1 over x2 minus x1. All right, and we have done that slope formula before, but I'm kind of bubbling that in again so you can see that. So these are two formulas we're just going to keep using over and over again. And what I'd like for you to recall is relationships of lines in the coordinate plane. If two lines have the same slope, so I'm going to say same slope, meaning they're going in the same direction, then that means they are parallel. So for example, if two things have the slope of 2/3 and 2/3, those lines would be parallel because they're going in the same direction. And then if two lines have opposite reciprocal slopes, they are perpendicular. Meaning they meet at 90 degrees. And some examples of opposite reciprocals might be 2/3 and -3/2. Notice this 2/3 and -3/2, the fraction is flipped upside down and the positive was changed to a negative. Another example might be -5/4 and +4/5. The fraction got flipped upside down and the sign changed from negative to positive. So let's just jump into our first example now that we've kind of covered some of this review stuff so you can see this in action. In example 1, it says, determine the most precise classification for the quadrilateral with vertices at these given points. What I want you to notice is it says most precise. So that means if it's a parallelogram, is it also a rhombus or what have you? Alrighty, so its vertices are A, B, C, and D. We want to graph these first. So A is at -4, 4. So let's do that. -4, 1, 2, 3, 4. Right here. This is A. B is at -2, 9. -2. Right here. C is at 8, 9. And D is at 10, 4. So I'm going to go over to 10 and then up 4. 1, 2, 3, 4. That is point D. Okay, and then, of course, we want to connect these guys. So I will do my best to connect them well. And I am going to put a highlighter on that just so you can see it a little bit easier, because I feel like that's a little tough to see on the dark graph. Okay, so there's my shape. And it is giving us a lot of information. It has told us the slopes of 4 line segments, and it's also told us the length of 4 line segments. So let's just look at the slopes right now. I have the slope of AB is 5/2, and the slope of CD is -5/2. Okay. These are not perpendicular. We know they're not perpendicular because this is not a reciprocal. These are not parallel as well. So we know that these two lines are not parallel. Now let's look at BC. That has a slope of 0, and AD has a slope of 0. So these two lines are parallel to each other. And we can go ahead and mark that on our graph as well. So I know that this line is parallel to that one. We would have been able to tell from the graph as well because we know that horizontal lines have a slope of 0. Okay, so we have one pair, strictly one pair of parallel lines in this polygon. Now let's look at our side lengths. AB, from here to here, its length is equal to the square root of 29. And CD, from here to here, its length is equal to square root 29. Square root 29 is the same as square root 29. So I now know that these two sides are congruent. So I'm going to mark that in my image as well. This guy is congruent to this guy. And now BC is equal to the square root of 100. AD is equal to the square root of 196. Those are not congruent. So I have one pair of congruent legs and one pair of parallel sides. Because it has one pair of parallel sides, I know it's a trapezoid. And because its legs are congruent, I knew they were congruent because they're the same length right here. It is an isosceles trapezoid. So I am going to put isosceles in front of that, SC. There we go. I was wondering where my error was. Isosceles trapezoid. And there's our first example. So we used the fact that we know what parallel lines, that their slopes are the same to determine that these lines are parallel. And then we used the fact that distance and length are going to tell us whether or not lines are congruent or not. In this next example, it's a little bit tougher. We don't have all that information, so we're going to have to come up with it ourselves. So it says, determine the most precise classification for the polygon with vertices, and then we have our vertices. So let's just graph those. J is at -3, -5, -3, -5. Excuse me. And then we have K at -4, 1. L is at 2, 2. And M is at 3, -4. Okay, now we want to connect these guys to form our actual shape. Okay. Now what we're going to want to do, we're going to try to figure out the slope of each side and the distance of each side. So I'm going to say slope of each side, and then I'm going to say length of each side. That's what we're trying to figure out. So let's just start at JK. So I'm going to say from J to K. And then I'll say M of JK. I also want to know how that relates to ML. So the slope of ML. And then let's do the bottom, JM. So the slope of JM, and I want to know the slope of KL as well. All right. Because we have a graph, I absolutely encourage you to just use the graph, and so you're not using that slope formula and wasting time. If you need to use the slope formula, you can. That's y2 minus y1 over x2 minus x1, or you can just use the whole rise over run thing because we have a graph that's already taken care of for us. So if I'm trying to find the slope of JK from J to K, I'm asking myself, how much am I rising and how much am I running? So I go up 1, 2, 3, 4, 5, 6, and I go backwards 1. So this one has a slope of -6 over 1. Okay, now if I find the slope of ML, how much is it going up? 1, 2, 3, 4, 5, 6, backwards 1. So it is rise 6, backwards 1, which is, once again, the slope of -6, 1. Or 6 over -1, it's the same thing, right? Okay, if I find the slope of JM, this is going up 1, 1, 2, 3, 4, 5, 6 over 6. So this has a slope of positive 1/6 because it's rise over run. And KL is up 1 over 1, 2, 3, 4, 5, 6 over 6. All right, so here's what I know so far. These two sides are parallel to each other, so I'm going to mark that. And these two sides are parallel to each other. And I know that because they have the same slope. So I'm going to mark that on here, parallel to him. And this guy is parallel to that one. So far we know it's a parallelogram, but also positive 1/6 is the opposite reciprocal of -6 over 1. So that means that all of these corners are right angles. So we now know that this is at least a rectangle. We don't know if it's a square yet, so that's what we want to figure out. We are going to figure out the lengths of all 4 sides now. So we want to know the length of JK, and I'll just keep it lined up from left to right. So length of JK, length of ML, of JM, and KL. So what we're going to have to do is plug our coordinates into our distance formula. So our distance formula, I will write it up here for us. Distance is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. And we're going to have to do that 4 times. This is a little bit tedious, but here we go. So I'm going to say JK is equal to the square root of this is at -3, -5. So I've got -3 and -5. And then I have -4, 1. Then I'm doing ML. And I'm just kind of getting this ready so I can quickly plug in my values into my formula. So if I know my x and y for the first one and x and y for the second one, then I can just plug those in accordingly. So ML, this is at 3, -4. And then L is at 2, 2. Okay. JM is the square root of, this is -3, -5. And then M is at 3, -4. Almost done. Now we're doing KL. KL is equal to, there we go, -4, 1, and 2, 2. Alrighty. We got everything plugged in. Now we can start simplifying. So this is going to become plus a positive. So this is -3 plus 4, which is -1 squared, plus -6 squared. Okay. This next one is going to be 3 minus 2, which is +1, squared, plus -4 minus 2, which is -6 squared. 3 minus 3, did I do that correctly? I just want to double check. So I've got J, which is -3, -5, and then M, which is 3. Oh, this is -6. I apologize. -3 minus 3 will get me -6 squared, plus, and then -5 minus -4 will be plus, so that is going to be -1 squared. And then down here, I have -6 squared plus -1 squared. All right, we are almost done. That is going to be square root of 37. This one is going to equal the square root of 37. This one as well, and this one as well. How am I doing that? So I'm taking -6 times -6, which is 36, plus -1 times -1, which is 1. So 1 plus 36 is 37. 1 squared plus -6 squared is 37, and so on and so forth. So all of these links are the same. I'm just going to write these up here real fast for you guys. And we now know, since all 4 sides are also the same length, because square root of 37 is the same as itself, all 4 sides are also congruent. If all 4 sides are also congruent, then that means that it is a square. This is a square. And I will kind of bubble that in because there was a lot of work on that problem. All right, we've got one more example. I promise it will not be as much work because it says, show that JKLM is a parallelogram by using its definition. What is the definition of a parallelogram? It is a shape with 2 pair of opposite sides that are parallel. So if we can show that this shape has 2 pairs of opposite sides that are parallel, then we are good to go. So we've got JKLM. We want to graph it. J is at -1, -6. K is at -4, -1. L is at 4, 5. And M is at 7, 0. Okay, now we want to connect these as best as we can. Okay. To determine if lines are parallel or not, we need to find their slopes. So let's find the slope of JK and the slope of ML. Then we'll also find the slope of JM and the slope of KL. So JK, I'm finding JK and ML, and I'm finding JM and KL. I'm finding the slopes of each of those. And I pair them this way because I'm interested in how opposite sides relate. So sometimes it's just easier to go ahead and put them in that order. Let's use our handy-dandy graph and count again. So from J to K, we go up 1, 2, 3, 4, 5, and left 1, 2, 3. So that means this has a slope of 5 over -3. For ML, how far up do you go? 1, 2, 3, 4, 5, and you go left 3. So that means I have a slope of 5 over -3. Let's do JM now. So JM, I'm going to go up 1, 2, 3, 4, 5, 6 over 1, 2, 3, 4, 5, 6, 7, 8. So this is going to be up 6 over 8. KL, how far up is that? 1, 2, 3, 4, 5, 6, and 1, 2, 3, 4, 5, 6, 7, 8. So this one's rise over run is 6 over 8 as well. So because these guys have matching slopes, and that means they are parallel. Same thing for these two. So because this pair of lines is parallel, in other words, this guy is parallel to this guy, and this one right here is also parallel to this lower one. I now know that I have two pairs of opposite sides that are parallel, so I'm going to say JKLM is a parallelogram because two pair of opposite sides are parallel. And there you have it. We are going to be practicing with this for a couple days in class, so if you're a little, unsure of yourself right now, don't worry, you'll be getting plenty of practice. If you have questions, please bring them to me in class, and have a good night.